uh, review your eight confidence intervals in two prompts. This should be really good for you. So if you're looking at this, I'm going to do a one prop Z interval, and I'm also going to do a T interval. So I'll do the T interval first, and then I'll do the one prop Z down here. This should be really good. This should be all you really need to get ready for the chapter 8 test. Okay, this is pretty good, pretty solid stuff. All right, first of all, a T interval. If you remember, the T interval, if you look at my hands on the screen, has a little bit of a wider base. That could be a multiple choice question. A little bit of a wider base than the Z curve or the infinity curve. Okay, it has a little bit wider base. And as the sample size increases, the T curve starts looking more like a Z. And for this class, we're going to pretty much do T's for means and Z's for proportions. And there's really those 90% of all statistics are means and proportions. So that's pretty much what we got here. Okay. Um, you know, T intervals show up in a lot of classes, though they may show up in your biomedical class. Some kids have told me that over the years. I remember that. If you have that, I would love to see that prompt so we could do it in class. But anyhow, all right. So here it is. Statman thinks the 1 ounce fun size, those 1 ounce ones are right here. Remember those little Snicker bars? Weigh less than advertised. I sampled 30 of these. I actually did this a long time ago, and they weighed just under 1 ounce. 0.995 is not a proportion. That's a whole number. That's a mean. That's a quantitative number with a standard deviation of 0.005. Okay. So the requirements, assumptions, conditions for this, the samples are representative sample. Um, the 10% rule, there are more than 300 snacks because shouldn't sample more than 10% of the population. Obviously, there's millions of these little snack things. All samples are independent. And then because it's 30 samples, we're going to be ensured a normal curve via the CLT. Remember, a confidence interval takes the middle 1/3, excuse me, the middle 95, why I say 1/3? The middle 95% of the data needs a normal curve. Okay. So here is how you would develop it. 0.995 plus or minus 2.045. Where did I get that? Degrees of freedom 29 on the formula sheet. Here's the standard deviation divided by the square root of n. Now, if you put this into like your calculator, some sort of software, Desmos does it for you too. And I'm not going to do the Desmos on this video, but you should know how to do that. I may make another one for that. So I might make a TikTok for that. So anyhow, and then so develop and interpret. Developing means one, you got to do this, you got to do the requirements. And really, I should have done check, 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 and I could have put, all requirements met. I could have done that. This is the developing of it. Don't just put this, it'll be partial credit because you didn't do the part on your own. You should know how to do this. And then it's real easy, the interpretation. We are 95% confident that the mean weight of a fun size Snicker bar is between 0.993 and 0.9969. Great. Okay. And then question B says, is there evidence to suggest that the bars weigh less than the advertised of 1 ounce, the average size? Okay. Use only the interval to respond. You don't understand why that question is being asked, but there are other ways to prove things in statistics. That's going to be chapter 9. Sometimes they'll give you a command on the AP test, use only the interval to respond, because there's multiple ways of doing that. And if I go to, like I said, if I go to Desmos, you'll see that pretty clearly. All right. And yes, because the entire interval is below 1. Notice I wrote, that would be enough of an answer, by the way. That's really all you got to write. But I wrote a little more. The highest the average weight could be in our interval is 0.9969, which is less than 1. Okay. Now, if you wanted the margin of error to be less than at most 0.001, how many samples would you need? All right, no problem. So this is just an algebra problem, okay? So just set it all up. Now notice I use 1.96, not this. Common mistake that kids will make. The reason is because this number is for degrees of freedom 29. I got to use the generic number. It's the infinity number, which I wrote here, the infinity number at the bottom of the page. You got to use a generic number and go ahead and solve this mathematically, algebraically. It comes out to be a little over 96. So to be within 0.001, you got to go to the next whole number, 97. Okay. And then this is the meaning of 95% confident. They also may ask you, what is the meaning of the 95% confidence level? They may ask that. That's a different question than the interpretation of an individual interval. They just want to know the generic meaning of 95% confident. And that one's, you've got to memorize the sentence frame. If we did this study over and over indefinitely, thousands of times, 95% of the resulting intervals would capture the true mean. 5% would not. I could have put about 95% and about 5% a little more accurately. And that relates to that activity we did the very first day of the chapter that you guys got a lot of oohs and ahs out of because it worked out so cool. Okay. So that would be pretty much the math on how you would do a T interval. Okay. Now, if you're going to do a proportion, we're always going to use Z's, which is actually easier. It's going to be the bottom of the page. So this, excuse me, is a this is a confidence interval. It's very typical. I got this just online. Donald Trump's approval rating fell to 43% in a sample of 1,000 voters, meaning 430 people approved of his job rating. In the fall of 24, it was 0.45. Now, it is a little bit different, but not much. And we're going to talk about that. Develop and interpret that interval. Here we go again. First step is the assumptions. Assume the following. The voters sampled are representative. Check. We're good there. Population of all voters is greater than 10,000. I just multiplied this by 10. It's the 10% rule. Don't sample more than 10% of the population. All voters independent. This is NP greater than 10 and N1 minus P greater than 10. So I know the fraction on this was 430 over 1,000 was the initial study. So really, is the denominator, excuse me, is the numerator bigger than 10? Yes. Is the denominator minus the numerator bigger than 10? Yes. Therefore, that's the three dots. The CLT will ensure normality. Okay. Next, you guys are going to put the interval together. Now, a confidence interval for proportion is a little different. 0.43 is the point estimate. The point estimate is called p hat, point estimate, plus or minus 1.96 for 95%. And then it's this estimate goes right there. One minus that goes right there, and then n. And then again, you're going to use software to do this. You're going to use your Texas Instruments software, or you're going to use Desmos. And then this is the interpretation. I am 95% confident that the proportion of likely voters who support Trump is between 0.399 and 0.461. Okay. Now, this one, is there evidence that the 2025 sample is lower than 24? 24 was 45%. If you notice, Trump's 25 rating could be as high as 46.1%. So there's not evidence because his 2024 rating, 0.45, is located in the 25 interval and is a possible answer. Anything in here is a viable answer for his popularity rating. Okay. And the next thing we're going to do is we're going to do the how many samples are needed to get the margin of error down to 1%. Okay. Down to 1%. Well, it's going to be 0.01 equals 1.96 times the standard deviation, and you're going to be doing a ton of algebra on this. Comes out about 9,415. That's a lot of samples. They're not probably nobody's going to really do that in a professional setting. It's just too many people to ask. It's too time consuming. They stick with around 1,000, which provides about a 3% margin of error. So, okay. All right. So there is that. Let's see here. I think I may try to show you Desmos. So let's try this. Okay. Get rid of this. Just hang on 1 second. No, I'm not going to do Desmos on this one. I'm just not going to work out. Okay. So that is it for that particular study. So that's chapter 8 review. Good luck to you.